Greetings, everybody. I wanted to just take a few minutes here and walk you through some of this seasons and ray angle review. At first glance, it can be kind of intimidating and what's going on here with all these things. But my hope is at this point, you've been through the lectures, you've been through the reading questions, the discussions and labs in class, and this is more review than teach. But it is what it is. We'll kind of go through this and I'll let you know at least what I was thinking when I came up with it. So obviously this isn't scaled well for size or really even distance. But what I was trying to show you is just, all right, here's the sun. And as the earth is revolving around the sun, we've got some different locations here that we should be getting familiar with. And these are our seasons. So we know that the Earth is a sphere, or more specifically, the Earth is an obloid spheroid. And I try to draw this little stick here in each of these locations to represent that 23.5-degree tilt. And that magical 23.5-degree tilt is really why we have seasons. It causes the rays and the days. Or you've probably heard me say the reasons for seasons is rays and days. That's true. But it's this 23.5-degree tilt that we think probably came from an early collision with the moon. But I don't want to get too far into all that again for today. So this isn't like four things. This is just supposed to be the Earth at four different locations and its revolution around the sun, or where it stops off along that orbit. So Earth is an obloid spheroid, and in each of these locations we could cut it in half, right? Or just kind of represent the equator. And now what we start to see is there's a time of the year when the northern hemisphere, which is where we live, so we're going to position ourselves or orientate ourselves from there. The northern hemisphere's tilt is leaning towards the sun, and there's a location over here where the northern hemisphere's tilt is away from the sun. So we've got these betweeners, but what I'm kind of hoping you start to see here is if I'm leaning towards the sun in the northern hemisphere, this must be summer. Or if you were saying this is the summer solstice, I would agree. So I'm going to jot down summer solstice. Now, there's kind of a variance here with the daylight hours and nighttime hours. I wasn't really looking for like an exact number, but I'm sure by now you're well aware that in the summertime, you come home from work or practice or whatever, and you notice that there's still an awful lot of daylight hours left. In other words, we have lots, not an exact number here that I was looking for, lots of hours of daylight. We're well over that 12 mark. We're getting towards like the 16-ish or 17-ish hours of daylight there, right? So our nighttime hours, we're going to put few, or if you wanted to put less or something like that. I need you to understand that as the sun's taking that longer trek or that longer path in the sky, it's getting higher in the sky, that's going to mean that it's visible and it's out for longer periods. That's not to say that, when I say the days are longer, I'm not trying to say that our rotation period of 24 hours changes. It's still 24 hours, ballparky, per rotation, but the amount of daylight hours or time that we see the sun is greater. So the sunrise direction. In the summertime, and this would be helpful if you've worked through the solar motion demonstrators by now, you can always go back and review those. But remember, the sun spends the bulk of its time in the southern sky, which is why we see most solar panels on southern exposures, or you put your sun-loving plants on the southern side of your home. So in the summertime, though, not only is the sun spending the bulk of its time in the southern side or the southern hemisphere or southern exposure there, but the sunrise direction will actually be way over towards the north. So this is where I would see the sunrise in the northeast, and the sun will then make its way all the way through southern side, and we're going to see that the sun sets in the northwest. So we've got some other spots on Earth, right? If this is 0 degrees of latitude, that would be the equator. And since we're at this 23.5 degree tilt, we've got 23.5 degrees north and 23.5 degrees south. Those will be basically the lines of latitude that the sun makes its way directly overhead back and forth. And at this point here, this would be the highest that we'd ever see direct rays in the northern hemisphere, and that's because the sun's rays would be overhead way the heck up here. So they're going to be directly overhead this line called 23.5 degrees north, or a lot of times what we'll refer to that as the Tropic of Cancer. Our sun angles, again, I'm not looking for an exact degree here. I'm just going to put high. They're going to be the highest sun angles we'll experience. So no, we won't have the sun directly at our zenith here in Michigan, but we're going to have very high sun angles. To technically have the sun directly overhead on the summer solstice, which happens at or around, June 21st, June 22nd, you'd have to be standing here on 23.5 degrees north. That line of latitude is called the Tropic of Cancer. So if we jump over to the other extreme, I notice that here, if I'm in the northern hemisphere, the tilt is away from the sun. And this is going to be where we experience the, sorry about that. I almost wrote just solstice. This would be the winter solstice. And like I said before, I didn't do a very good job of scaling size or distance. You should be at a spot now where you understand we're actually closer to the sun in the winter than we are in the summer. And that's counterintuitive, right? Sun's our heat source. You get closer to the campfire, you should be warmer. Well, it's like on average 96, 97 million miles, and there's a few million miles that we're closer here, but that doesn't nearly make as big a difference in how we receive energy as whether we're tilted towards or away. So the winter solstice, again, I wasn't looking for like an exact number here, but I know that my daylight hours, or time that I'm facing the sun there, is now going to be few. We're under the 12 and 12 mark of splitting our days. And my nighttime hours, there's going to be, lots. The sunrise direction, now the sun just pops out in the southeast and sets in the southwest. So yes, the sun's still spending the bulk of its time here in the southern exposures, but we're not going to have it rise way over in the northeast and set all the way in the northwest. And our sun angle is going to be really low. So the latitude that the sun's directly overhead here now, remember if there's our equator at 0 degrees of latitude, and we talked about how the sun's directly overhead 23.5 degrees north for the summer solstice, it's directly overhead 23.5 degrees south for the winter solstice. And this 23.5 degrees south, this is called, I probably should have done a better job of giving myself some space to write here, right? It's called the Tropic of Capricorn. And I know that those aren't probably locations that you're usually describing to friends, but the way that I always kind of kept it straight when I was a kid, I'd think, all right, well, Cancer is a smaller word than Capricorn, so I could stack that on top. And another little trick that I'd sometimes use to remember which one was the north one, Cancer, it's got the N in it first. I get Capricorn's got an N in it second, but I think N, north, okay, that's the north one. Maybe that'll work for you. You're probably smarter than me. You can just keep it straight. But anyways, so these are our extremes, right? We've got the solstices leaning towards the sun, highest sun angle rays that we'll experience in the northern hemisphere here on the summer solstice at or around June 21st. And then we've got the lowest rays that we'll experience. The sun just barely pops out. That would be at the winter solstice at or around December 21st. And that's going to be our low sun angles, and the sun's directly overhead the Tropic of Capricorn. So say that's you. And we've got these different sun angles. In the wintertime, the sun's relatively low in the sky, pretty low angle of insolation. In the summertime, the sun gets high in the sky. And this is for Michigan, right? I mean, there are locations where the sun just beats down basically directly overhead. But I just wanted you to kind of see what I mean when I talk about like a low or a high sun angle. The sun is higher, and maybe you've noticed if you've got like second story windows that different times of the year the sun can come through at different times. That's because it's taking a different path in the sky. So we've got some betweeners, right? If I take a look at this, I've got these betweeners. And this is where things are going to be equal, or the equinoxes, which is Latin for equal nights. So if we're making our way from summer to winter, this would be fall. Or we could refer to this season as autumn, or this would be the autumnal equinox. And that's where we're going to have equal nights, or equal day, equal night. You'll have 12 hours a day and 12 hours of night. So these guys, my daylight hours, my nighttime hours, I can fill in a numerical value. We're getting 12 hours of each. And this is where we say that the sun rises due east, or exactly in the east, and it sets exactly in the west. And if I go back to my little sketchy sketches here, right? If I had 23.5 degrees north, summertime, 23.5 degrees south, wintertime, where the sun's directly overhead, split those bad boys in the middle, the sun would be directly overhead the equator. So if you're standing at 0 degrees latitude or the equator at the autumnal equinox, you'd find that the sun goes directly overhead. That'd be 0 degrees, the equator. And I'm just going to put mid for the sun angle there, because if we're in Michigan, and if this is supposed to represent like my winter solstice sun angle, and this is supposed to represent like my summer solstice sun angle, then the equinox, that's going to be smack dab in the middle there. So I'd have 12 hours a day, 12 hours a night. Make your way from lots of sunshine, less and less and less, until you get to about that 12 and 12 point. And then you actually experience less daylight hours than nighttime hours. So you're going to have less and less and less until you experience the shortest days of the year. Again, not less than 24 hours, but hours of daylight exposure. That's that. And then after the winter solstice, what you'll start to see is you're slowly gathering more and more hours of daylight until you get back to that 12 and 12. The other equinox, that's referred to as the spring, or the vernal equinox. And again, we can plug in a numerical value here. 12 hours a day, 12 hours a night. Sun rises exactly east, sets exactly west. If you were standing on the equator, which is 0 degrees, you'd have the sun go directly overhead. And in Michigan here, that would be like a mid-angle for us. So here we're back to 12 and 12 hours of daylight, and then we start to experience more and more and more hours of daylight until we get to that summer solstice. So some things that are sometimes confusing for kids: if we say springtime, that's actually a location in space. So time and space, they're intertwined. You can't pull them apart. To say spring, you're talking about a location in space. And even though it may not be spring-like, you can be in spring. So these are some things that you should be able to keep in mind. Just to walk you through this first question here, if I was teaching this to kids in Australia or somewhere in the southern hemisphere, you'd find that this is all flip-flopped. But we orientate ourselves from the northern hemisphere because we're at, of course, about 42 degrees of latitude there. If you've got questions, concerns as you're making your way through the rest of this, please let me know. With this here, again, just to kind of walk you through it real quick, this would be the reverse of that. This was supposed to be sun. So the sun at position A, if there's like my equator, this would represent like the 23.5 degrees north, and this would represent the 23.5 degrees south, or the Tropic of Cancer and the Tropic of Capricorn. So this is going to be your summer solstice. This guy down here way at sea, this would be your winter solstice. And then twice a year, the sun's over the equator, or this would be your equinoxes. And it's basically just making its way directly overhead this equatorial region called the tropics, between these tropics of Cancer and tropics of Capricorn. And that's why it's so darn hot, amongst a few other reasons that I'd like to talk to you about later. But I think that's enough for now. Like I said, if you've got questions, concerns about any of this, please ask me in class or shoot me an email. Until next time.